Last lecture we have seen the finding the method of initial basic feasible solution of the northwest corner rule. In this lecture we have seen the algorithm for row and column minima method or least cost method of the finding the initial basic feasible solution of the transportation problem. That is, in this method, row minima or column minima, we have seen the algorithm of the finding the initial basic feasible solution of the transportation problem for row and column minima method or least cost method. In that is in the uh, in the transportation matrix, cost matrix, select the smallest transportation cost cell available in the entire table and allocate the supply and demand. That is, first we have procedure, that is, select the smallest transportation cost cell in the cost matrix, and here allocate the supply and demand, that is the minimum value of supply and demand. We have allocate the smallest transportation cost cell, I'll make the allocation and delete the row and column which has exerted, and the delete row and column must not be considered for further allocation. That is, here fulfill the supply or demand, that is delete the row and column and which has exerted, and delete row and column must not be considered for further allocation. And again select the smallest cost cell in exiting table and allocate, that is, in case if there is or more than one smallest cost, select the cell which where maximum allocation can be made. If there more than one smallest cost, then select the cell where maximum allocation can be made and obtain the initial basic feasible solution. That is, this is the algorithm of the finding the row and minimum method or least cost method of the finding the initial basic feasible solution of the transportation problem. And we have seen the numerical example of the least cost method. That is, first we make our understanding better. Let's us go through the numerical example. In this table, there is three factory, that is origin 1, 2, 3, or retail shop is 4, 1, 2, 3, 4, and supply is 50, 75, 25, and demand is 20, 20, 50, and 60. Here we have first check total supply equal to total demand. Here total supply equal to 150 and demand equal to 150, and therefore given problem is balance transportation problem. And apply the least cost method, that is, first we have select the minimum cost in the transportation table. Here minimum cost of the transportation table is here 2. We observe that C21, which is the minimum transportation cost, and so X21 is 20. Here we have select the minimum cost is 2. In this transportation table, here minimum cost is here 2 1 cell is 2, and 2 4 is 2, and here 3 4 is 2. Here 3 minimum cost in this transportation table, and we have select the x to 1 equal to 2. That is, in this second row we have the maximum allocation. Therefore, we have select this cell to 1 equal to 2 and make the allocation. That is, here supply is 75 and demand is 20. Here minimum is supply or demand equal to 20. We have allocate the 20 in the cell to 1, and here cross out this column, and here remaining is 30. Next we have select the minimum cost is 2. That is, here we have allocation, that is, here remaining supply is 55 and here is 60. We have allocate the 55 in the this minimum cost, that is 24 is 55, and here this cross out this row, and here remaining is 5. Then next minimum cost is, and again second, and we allocate this remaining demand is 5, and we have allocate this 5 in the cell 3 4, that is 5, and here column 4 is cross out, here cross column 4 is 0, and here remaining is 20. And next minimum cost is 5. That is, here we have select this 1 2, and we have allocate, that is demand is 20 and supply is 50, and here allocate minimum supply or demand is 20, and we have allocate the 20 in the cell 1 2, and here remaining 30, and here cross out this column, and we have moved to the next minimum cost is 7, and we have allocate this remaining 30 and here 50. We have allocate the 30 in the cell 1 3, and the cross out this row, and here remaining 20, and last remaining the cell 9, and here we have allocate the 20 in the cell 3 3, and here remaining supply is 30 and remaining demand is 20. Remaining supply is 20 and remaining demand is 20, and we have allocate in the cell 3 3 is 20, and here number of allocation is 1 2 3 4 5 6, and number of basic variable is m plus n minus 1, 3 plus 4 minus 1 equal to 6, and number of allocation is 6. And finding the total transportation cost is, that is 5 into 20, 7 into 30, 2 into 20, 2 into 55, 9 into 20, and 2 into 5, and here total transportation cost is 650.